Hello and welcome back. Today we're going to be talking about the normal force. Now, that sounds like a silly name. What is a normal force? Well, let's define it. Let's say I'm on the ground, right? Now, what forces are acting on me right now? Well, you'd probably say gravity, right? The force of gravity is going down. Now, is that all? Well, it can't be. If it was only gravity, my net force would be pointing down, and I'd start tunneling into the earth to accelerate. There must be some force that is counteracting it to make a net force of 0 since I'm not accelerating. And there is such force. It's called the normal force, often written as Fn, not to be confused with Fnet. Fn is not the same thing. So what is the normal force? It's the force that points perpendicular to the surface to counteract the force of gravity. Let's say that this little guy is 50 kilograms. What is the normal force of this person given that they are not accelerating? Well, let's find out. We can use sum of forces equals ma, and we know that there's no acceleration, so sum of forces has to be 0 since acceleration is 0. And so what forces are working on the guy? There's the force normal and the force of gravity. So our sum of forces is going to be Fn plus Fg equals 0. These forces are pointing in opposite directions. Shouldn't one of them be negative? Yes. And let's say down is negative. So the real sum of forces is going to be Fn minus Fg equals 0. And if we move Fg to the other side, we have Fn equals Fg. That means that the force of gravity in magnitude is equal to the magnitude of the force normal. And that should make sense, because if they were not equal, this guy would have a net force and would start accelerating. Fn equals Fg, which equals mg. And we know the mass is 50 kilograms, and g is 9.81 meters per second squared. If you take out your calculator, you can see that Fn and Fg is 490.5 newtons. So the calculated normal force is 490.5 newtons. All right, that was a quick summary about the normal force. Good job and happy learning.